Okay, so in the last class, we were discussing regarding the order of reaction, and I told you in a very simplest way that what is the order of reaction? Order of reaction is basically the influence of a substance uh, on the rate of chemical reaction. Okay, that is considered as the order of reaction. And when we will be calculating the order of reaction, we need to calculate it according what? We need to calculate it for one particular substance, order of one particular substance, then we will be calculating the order of the second substance. Is it clear?
Yes, sir.
Okay. Then we discuss about the rate constant. I told you one major point here that the rate constant value does not change. The rate constant value does not change and it has no influence, it has no change according to the change in the concentration of reactant, one or more of the reactants. But its value will change when the temperature changes. Okay, its value will change when the temperature changes. We discussed about the units of rate constant, like we discussed the order of reaction for the zero, first, second, and third order reaction. We discussed about the units, and I told you that we will be calculating the units for the rate constant when we'll be doing the numericals. Is it clear, Bete?
Yes, sir.
Okay, okay. Now give me a minute. Okay. Before going towards the what we say the next part, I'll let you know that we see a rod of metal, and we see that rod of metal on any of the surface, like we see that rod of metal on our rooftop. Okay, and when we are observing that rod of metal on the rooftop, we observe that with the passage of time it is becoming weak. Am I right? Every substance has its own half life. Every substance has a lifespan which it has to cover. Okay, every substance has a lifespan which it has to cover, and that lifespan is just gradually we can say that making it move towards the end of that material. Okay, every material has its own half life. Every material has its own half life. But before going towards the half life, let me tell you some other things here. What is the reaction mechanism? Let me tell you regarding the reaction mechanism. What do you understand by this word mechanism here?
Reaction step or reaction process?
Exactly. Mechanism is basically considered as the steps. Let me give you an example. Do you eat biryani?
Yes, sir.
Okay. Let's see that we have rice, we have meat, we have spices. These all three things combine and they will be producing what? The biryani. A people, let's say a person like me that who doesn't know that how to make biryani and how to do the kitchen codes and anything, like I consider that when we mix these two materials, these three materials, rice, meat, and spices, it will become biryani, like a magic. But the mother and the female who worked in the kitchen usually know that, and the people who know that how to cook, they know that there are some steps of processing through which the rice will go, the steps of processing through the meat will go, the steps in which the spices will involve, and at the end, after so many steps, we will get the biryani. So every chemical reaction involves the steps. Okay, every chemical reaction involves step. We observe that in many of the chemical reactions, we have many reactants which are participating for producing the product. Okay, if any of the chemical reaction is proceeding in a single step, then the reaction would be slow indeed. Okay,
Okay.
let's see that. we consider a chemical equation here that A is reacting with B and C, producing the D and E. We need the three reactants here, okay? We need the three reactants. If I just consider the rate equation, what will be the rate expression here? Can you tell me that? The rate is equals to,
K equals bracket A power 1 first
don't say
order
that the
bracket
bracket
B
A, don't say the bracket A. It's like the
concentration of A
exactly. The concentration of
yeah, my
A,
bad.
the
Concentration of A,
concentration of B.
concentration B, and concentration of C all in the first order.
Okay, if I say that we are not considering the concentration of C here, why? Let me tell you
Because
that.
the concentration of C does not have any effect on the rate of the reaction.
Okay, that changes the concentration. The change in the concentration of the C will be the negligible effect, or will be no measurable effect of the concentration of C on the rate of reaction. Okay, that's why I'm not considering it. Okay, this is not the
Okay.
case that the change in the concentration does not really affect the overall rate of reaction. It will affect, but the influence of C is so much, like we can say that the does not appear in the rate equation. Why? Because it has a very negligible effect. Okay, there must be a step involving for involving the C in it. Let's see that the A and B are the major reactants. The C is involved in another reaction. Why? Why? Let's say that this overall reaction, this is what this is. Let's say the overall reaction. This is the thing. This is the thing that I consider rice, meat, and spices mixed with each other, and they will be producing the biryani. This is the thing. Okay. But when I observe this overall reaction and I will distribute this overall reaction, or we can say just separate this overall reaction into the multiple parts, I will be observing what? In case, let me tell you, there must be a step involving the reaction between the A and B that has an effect on the rate of reaction. Let's write that step. It is like A plus B is producing the Z. That step is the slow step. Why I told you the earlier that the step, basically the chemical reaction which is happening in the one step, it must be the slow step indeed. Why I told you that? The reason is that slow steps are the major ones. Okay, always remember that. Slow step
Okay.
are the major one. Okay, let's
And
see.
sir,
So,
fast steps भी क्यों नहीं होते? Like,
because
what's
the
the
thing is,
reason
in
why
this,
it's only slow?
हम इसको complete करते हैं ना, फिर I explain this question to you.
Okay, okay, okay.
And we have this Z here. We are not observing any Z here in the overall reaction. Z is basically the intermediary product. It's basically the transition product here. Na? It will transfer into the other substance. Sir, we didn't react the C here. We haven't used the C here yet. Now we will be using the C. That is basically the past step. Okay. It's like A and B that has an effect on the rate of reaction. There must be also another step in which the C reacts. You see the step 2 here. In the step 2, the C is reacting. Let me mark it here that step 1. Then we have step 2 here. Okay. Is it clear? But this reaction has no effect on the overall reaction, overall rate of reaction. This could be explained simply by just distributing any equation into the two or three different parts in which we will be observing the slow step and the fast step. You can see that assuming the reaction A and B is taking place here and forming the Z, which is then reacting with the C. C is not react earlier in the first step by any chance. It is not reacting there. The reason is that A and B are the major reactants which will be producing an intermediary product here, and this intermediate product or the transition product will then react with C. Okay. If this were the case, then the mechanism will be like this one. This is the one mechanism. This is the mechanism, the steps here. Okay. So which step is the rate determining step? Let me write this sentence. then at the end of the part here, we will be moving towards your question. Rate determining step is always the slow step. Okay. So in this example, the above example, which one is the rate determining step? Am I
Always
audible?
B
Shan,
equals.
exactly, Shanizera. The step one is basically the rate determining step. Always remember, it doesn't mean that the step one is the what we say, the slow step always. Maybe the step two is slow, maybe the step three is slow. There's a possibility. The thing is that the slow step is always the rate determining step. Okay. Now let's see
Yes,
that.
sir.
Move towards your question. Acha, before moving, let me write some major point here. Write these points, then we will move towards your question.
Okay, sir. G, sir, done.
Okay. If I'm saying the word slow, it means what? If I have the two considerations, the
Um,
slow and fast,
a lot of
if I'm
time is being
it
taken.
takes a lot of time. And if the thing is taking a lot of time, it means that it is happening at a slow pace and it is happening in a lot of time and it is producing the product which has the influence. Okay. It has the reactants which are taking complete part in a reaction. Let me give you a very simple explanation. If you say that the rate determining steps are the slow steps, why? The thing is that the slow steps is the rate determining. Why? Because the overall rate cannot be slower than the slow rate. Let me clearly explain this thing more to you. The slow steps takes most time. It is considered the most important. Why? The fast steps take less time. It will take a very short time. The slowest step requires more time to happen as there can be several other processes involved in the completion, but this step is the major one because it is involving the total concentration of the reactants, those reactants which are basically involved in this step. It is taking the total concentration of those reactants in the chemical reaction and converting this whole concentration into the product. Eventually, when we are determining the rate of reaction, we have the three different types of reactions: slow reactions, fast reactions, and moderate reactions. Okay. As you see that when we are distributing any of the chemical reaction into the two parts, we will be saying that this is one is the slow and this one is the fast. If I say that a cheetah, a lion, let's say lion, and a snail, lion and a turtle, let's say a lion and a turtle, which one is fast?
A lion,
Okay. If I consider a lion and a snail, which one is fast?
a lion,
No, 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 no. A lion and a turtle. This is the first scenario. Which one is fast?
The
Lion,
lion.
and
Yeah.
a turtle and a snail. Which one is faster?
Oh, turtle.
Why turtle? In the earlier case, you said that the turtle is the one which is the slowest one, and now you're saying the turtle is the fast one. Why?
Because you give me two different options. One was with the lion, and one is with the snail. So like I'm comparing.
The thing is that in both of the scenarios, we are observing that the relationship or the consideration we are doing here, the comparison we are doing here basically is different. In one of the comparison, we have the slow person, which is basically the turtle, and in the second comparison, we have slower than the turtle. Am I right? So
Yeah.
whenever we consider the two materials or the two reactions, we will be saying that the slow and fast, not the moderate. Eventually, when we are calculating the rate of reaction, if you just put the acid, a concentrated acid, on any of the salt, there will be a rapid reaction. We're not able to calculate the rate of reactions of very rapid reaction. And if I ask you that, Shane Zera, what's your age, by the way? What's your age?
I'm 16.
Okay. Shane Zera, how many centimeters your height is increased on this particular day? On, let's say, the 12th of September. How much your height is increased now, today?
0.001.
No, it's not that. It's negligible. You're not able to calculate that. If you are
Okay,
standing
yeah.
in front of your mirror, in front of the mirror, let me give you an example. When we meet people after so much time, now like months or years, they usually say, "यार मोटे हो गए हो, यार दुबले हो गए हो, यार जरा लंबे हो गए हो."
Gee,
These are the things. लेकिन हम
yeah,
we
like I
are
remember
we
in COVID also this happened. Like we came to school and they were like, "Oh my God, people have changed."
Exactly. The thing is like you're so much changed. You're so changed. The thing is, when I hear these kind of things from me, the, I'm really observing myself in the mirror regularly. I see myself in mirror, and I'm observing no change in me. But the person in front of me, he or she is observing some changes in me. The reason is that there is a time distance. There is a time duration. After that time duration, he or she is observing me. Okay. The thing is, we need to calculate the rate of reaction on the basis of time. If I say the rusting of iron, it is not a considerable reaction. We never calculate the rate of reaction for rusting of iron because it takes a lot of time. We're not able to calculate your height on the basis of the rate of reaction because it takes a lot of time. A lot of time. Okay, so we calculate the rate of reaction for the moderate reactions. And when we see and when we divide the chemical reaction into the two parts, the slow and fast, the slow one is the one which is taking a lot of time, a considerable time. Okay, it is taking a considerable time. And this is the main reaction in which the total reactant is converted into the product. It is taking the total part. That is why the slow reactions are always the rate determining steps. Is it clear, Bete?
Gee, sir.
I guess now your concept is clear.
Yes, thank you.
Okay. Now let me. Okay, we'll do the questions after the end of the chapter. We'll do the questions after the end of the chapter. Let's move towards the next thing. Let's move towards the topic, which is the half-life. Okay, now what is the half-life? That is basically a
Um,
part for determining the rate of reaction. So this the half-life is a rate of reaction consideration. No, we're not able to understand that how the half-life is just related with the rate of reaction. Let me tell you that if I say that 1 kg of substance X, okay, it is becoming the 75, sorry, 750 grams, sorry, 750 grams in 10 minutes. Can you tell me that what is the half life of this material? This is a reaction happening. It is just consuming, it is just releasing, it is vanishing in the thin air, and anything which happens to it. But I am just saying that the 1 kg of the substance X is just becoming the 750 grams in 10 minutes. Now I'm asking you that what is the half life? It is taking 10 minutes to become the 750 grams. It'll take 20 minutes for making the 50 grams, 500 grams. Am I right?
You're
1 kilogram of a substance will become 750 grams in 10 minutes. You getting it?
G.
It is consuming, it is just releasing, it is just vanishing in a thin air. Let me give you an idea. Regarding the nail polish remover, it's the thinner.
G.
When you open the bottle and you leave it open, after a while, what will happen? It'll vanish. Am I right? The nail polish remover.
Yes. Yes. Yes.
Normally, nowadays in the market, when we have a nail polish remover, it's a very thick material like the glycerine is added in it. The glycerine is added for a purpose to make the thinner stay in the container. Glycerine is basically a catalyst which is just making the reaction slow here to make the thinner release out slowly. This is the phenomenon. But if I say that I have a 1 kg or 1 liter of one unitary method of the substance X, and it is just decreasing its concentration, decreasing its amount, in the 10 minutes it will become 750 gram. And I'm asking you that what is the half life of the material? You have to calculate through a pattern. You need to apply some analogy in it. You need to apply some calculation in it. Okay. So what is the half life and where it is coming from? When we will be determining the rate equation, when we will be determining the rate equation, or you can say the mn value, which are like the 0, 1, and 2, we have the two methods. There are the two methods for determining the order of reactions. Okay, two methods for determining the order of reaction. Let me write those two methods first, then we will be moving. Two methods for determining the order of reaction. The first one is basically the graph method, or you can say another name to it, that is basically the concentration time graph. Have you ever seen a concentration time graph?
Yeah.
Second was basically the half life of reaction. Is it clear?
G, sir.
Okay. Let me tell you that first the concentration method is here. Okay, so that is the concentration time graph. Okay, so what we will be having on the x-axis, we will be having the time, and then we will be having the concentration here. Let me put some points here. It's like 0 to 100. Then we have the 200. Then we have the 300. It's like, okay. Okay, let's see that this is basically the curve here. Okay. And this is the concentration for what? Let me put it there. Concentration of
Reactants.
reactants. Exactly. The first value here is like, let's say 120. Okay. On 100. Actually, it's kind of a rough graph from my side. So if I just give you a very simple value for understanding, it is like this is the value here. And let's say that this is the 60. Do consider this as a rough graph. Okay.
Okay.
So this is basically a concentration time graph. And now I'm just putting the half life here in the same thing. This is the first half life. This is the second half life. And that is the third half life here. Is it clear how it is? Let me tell you that. Half life is basically a constant value. Okay. Half life is always a constant value for us. Half life is always a constant value for us. How we'll be putting this concentration time graph? We have a values for concentration time graph, and we will be putting those values according to the thing, and we will be putting the curve according to the values. And the half life is basically the one which we predict or we can calculate. We are observing that in the first half life, it is just moving from 0 to the 100 seconds, and the value is just becoming 60, from 120 to 60. That is the first half life. It's like what? 120, half of it is become 60. That is the first half life. Okay. It takes 100 seconds. Another 100 seconds will never take the 60 again. It will take the half life of this 60. Are you getting my point? That what is half life?
Yes, sir. Like the time it takes for like something to decay or something to
Exactly
do
the
stuff.
time for decaying of material. But the concept here is what? The first 100 seconds will remove the 60 grams. If I say 60 grams of the material, and it is just making move from 120 to 60 in the 100 seconds. Now in the next 100 seconds, it will never be zero. It will become 30. You got my point? That the half life is always according to the recent material, not the initial material amount. It is always according to the recent material amount. It's like 120 initially, it will become 60. Now 60 is the initial here. 60 is the one on which we are working. That on 60 grams, after the 100-second passage, will become 30 grams. And after this, what will be the mass? Can you tell me? This 30 grams will become what?
15.
That's good. If I ask you that again 100 seconds, it will become what?
It's gonna be 7.5,
And after again the 100 seconds, it'll become what?
3.75.
3.75. That's good. Did you get my point? That when we are
Yes, sir.
decreasing, when we are calculating the half-life of the material, we will be observing that initial will change into the final, then final will become initial again. Is that clear? So all three half-lives are the same. The reaction in the it's the first order. If the half-life is changing, half-life is fixed basically. If the half-life is changing, so we will be going to proceed that what is the order. Then we will be proceeding towards the calculation. So if the order is second, third, or which one here. Is it clear? This is a
Yes, sir.
curve. If I say that I have the graph like a straight line. Now, what are the values and how we will be discussing it? Let me tell you that. We will be having the time here and we will be having the concentration here. If I say that I will be having a value which is basically a straight line. If this is the line, if the graph is a straight line with a negative gradient, then the rate of reaction is constant no matter what the concentration of reactant is. No matter what the concentration of the reactant is. Okay, let me put some points here so that you will understand and you'll note down these points as well for you. Since all three half lives are same, the reaction is first order. Okay, is it clear?
Ji, sir.
With respect to concentration of reactant, if I just put only one reactant here, so it's totally depending on the one reactant. If the half life is change, let's say if half life doubles as reaction proceeds, then the reaction is second order. Did you get it? Did you get it, Bete?
Ji, sir.
Now let's see this one here. Okay, let's say that, let me write the points here for you to understand. If the graph is straight line, what does the negative gradient means? Shane Zaira, what does this negative gradient means?
Uh, I don't know.
The curve is declining.
Yeah.
That is why it is a negative gradient.
Oh, okay. I was thinking there might be a complex answer to that question
Why?
because like most of the time, like the easy questions have like a complex answer. So I was like, what kind of answer would it be for this one? I didn't think it
Nahin,
was gonna be this
I
simple.
will be, let me tell you that. There must be a concept for every answer. There must be a concept for every question, and question will give you the answer. See that I didn't ask this question that what is the negative gradient here in this curve? This is also declining curve, but that's not a complete declining curve. This is a declining curve, a complete declining curve which is going down, a downward curve it is basically. Is it clear? So let's see that if the
Okay, so
graph is a straight line with a negative gradient, then the rate of reaction is constant. Do we have a rate of reaction constant in this curve?
uh no,
How do you know that?
because like a constant is like the one that you
If
just
I
showed below. This is
see
like a
this, see
gradual
this.
decrease.
Can you repeat your answer again?
I was saying this is like a gradual decrease. It's constantly changing.
If it is constantly changing, so it is a constant rate of reaction. It's not constantly changing,
See,
bete.
yeah, yeah, makes sense.
It is not constantly changing. Let me tell you that. Let's say that when you're back from school and you're so much hungry, so much hungry, so much hungry, okay, and you're on your dining table and your mother just gives you the food. At the very initial part, your hunger is on what level? Peak. Am I right?
Yes.
And you start eating very, 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 very fast, very fast. With the passage of time, what will happen? At very initially, you think that this plate is not so much for me. This plate is not enough for me. I need more food. But with the passage of time, what will happen?
You're like
You,
overeating more than you actually need to.
your hunger